Hello everyone, welcome to today's video where we are going to delve into the world of S.O.L.I.D Principles in software development. I am Nouman, a passionate software engineer, and I'm excited to guide you through understanding the concepts of single responsibility, open closed, Liskov substitution, interface segregation, and dependency inversion principle. Before we dive into the individual S.O.L.I.D principles, let's take a moment to understand what these principles are and why they are crucial for writing high quality and maintainable code. First of all, the S, single responsibility principle. The single responsibility principle, or SRP, suggests that a class should have only one reason to change. In simple terms, a class should have a single responsibility or task. By adhering to SRP, we keep our classes focused, making them easier to understand, maintain, and test. Now let's explore how SRP works with two examples, one that violates the principle and the one that adheres to it. So here we see a struct report and an implementation of that report called generate, and that have two functions, generate report, and that generates reports and give it, and then send report by email, which sends the report to the email. Now this is good, but it's not focused. Like the report clause should always have the report stuff thing, but not the stuff like generating or sending it. So here's the second example. Okay, so here you see there's a struct report generator here, and then we have the implementation for the report generator, which takes the data and logic for generating a report and return it. Then we have another struct called report saver that implements the save report function, and then a report email sender and that function. So this is the example that adheres to the SRP, and believe me or not, but this one is way more maintainable. If you want to change any logic for saving reports and stuff like that, you can just go right here into the function. If you want to send report, you can just go here and go into the send one. That's it. So you gotta implement these by just separating clauses. It's not that hard to implement, and it makes your clauses a lot more focused and is part of one S.O.L.I.D principle. Now let's look at open closed principle. Let's look here. So I'm going to open up the OSP. So here you see, first let's talk about what open closed principle is. Moving on to open closed principle, or OSP, this principle advises that software entities should be open for extension but closed for modification. In a sense, once a class is defined and working, it should not be modified to add a new feature. Instead, new functionality should be added through extensions. Let's see this. This is actually one of my favorite ones. OCP promotes flexibility, allowing us to add new features without altering existing working code. Let's look at the two examples, one that violates OSP by requiring modification for a new feature, and another that adheres to it by allowing extension without modification. So here we see that there's a process payment function in the payment processor class or struct. And it has the logic for processing payment, but when we add more payment methods, it should be modified. But here it's the same thing if we look at the one example that does not. Now obviously the code is a little bit more, but it is worth it. So we have a payment trade which has a function of process. And then we have a create call payment struct which implements the payment function, payment trait and the process function. So we have the logic for credit card payment, then we have PayPal payment, the logic for that, and we can add more stuff, like let's go pay some payment, and we have the struct, and we can have the implementation for that specific payment, and we can have the function process, and we can have logic. This is as simple as it is. We don't have to change the payment trait itself or payment struct if you prefer. Now let's move on to the another one, which is Liskov substitution principle. Now this one is kind of a little hard, but the Liskov substitution principle, or LSP, states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. In other words, subclasses should maintain the expected member of superclass and avoid introducing surprises and breaking existing code. LSP ensures a consistent and reliable behavior across different objects in a hierarchy. We'll explore LSP through two examples, one that violates LSP by introducing unexpected behavior, and another that adheres to it by maintaining consistent behavior. Let's look at that. So LSP1 or F. So this is a simple program. It's not very hard, but it's actually very easy to understand it. This one is the best example you can get about understanding LSP. So you see, we got a struct called bird, and then we have the implementation of it for fly. Now, if someone's creating a struct, a bird object, and it's trying to run the fly, but it's doing it with ostrich, which is implementing the bird. This is where the problem comes in, because ostrich can't fly. This breaks unexpected code. Now to solve it, we got our LSP principle, or the Liskov substitution principle. Now here we get a trait bird, which have the fly function as we expected, and then we got a sparrow, which have the sparrow function flying, and then an ostrich which can't fly. So this one is creating different structs for each of them, which also applies the S.O.L.I.D principles. First one, which is the single responsibility principle. So now what we have to do is, this is the thing. Now let's talk about the interface segregation principle. This one might be a little not hard, actually. This one's pretty easy. Let's discuss the interface segregation principle, or ISP. This principle suggests that clients shall not be focused to implement interfaces they don't use. By adhering to ISP, we create smaller and more focused interfaces that cater to specific clients' need. This leads to cleaner, more maintainable code, preventing unnecessary dependencies and unused methods. Let's delve into the two examples, one that violates ISP by imposing unnecessary methods on the client, and another that adheres to it by providing specialized interfaces. So this one is actually something that is pretty, like, you can understand it very easily because it's more of a client-side thing rather than the maintainable code thing. So you see, we got a trait called worker, which have the work and eat function, and we got a struct engineer, which implements the worker, and it has a work and eat. So this implements two functions. This is the one that violates it. Why? Because we are creating a non-struct and yeah, this is not good anymore. Let me show you. It's not what you can understand without showing the example. So now you see, instead of having that worker thing, now we got an eater thing as well, and engineers should implement both of them. So for example, manager don't eat. So this is pretty unique because engineers don't eat. Like, we don't want to implement that. So we got a worker trait and a eater trait, yeah. And then we got an engineer struct, and then an implementation for engineer, which have a work function for engineers work. And then we got a manager, which got both of them. So you see, like, we don't have to, like, we create small and more focused interfaces that cater to specific client needs. You get it. Okay, so this one's not much used right in most people works. Let's talk about the one that is most important: dependency inversion. Let's go DRP. So data service, we got this data service right here, which fetch data, which have two functions: fetch data from MySQL and fetch data from Oracle. This is kind of same through the single responsibility principle, but it's very different. So we got this thing. We are fetching data from MySQL and fetching data from Oracle. Now, obviously, you can tell this is not clean code. So let's go into the second one, which is implementing the database, which have a func of fetch data and then a struct MySQL database, which have its own fetch data function. Oracle database, another fetch data function, and then data service is a struct which have a database. Now it's also taking a type generic, which should be database as well. Now this is something very cool. Like, type generics are very cool. So data service is taking a specific clause that implements the database thing. So actually you won't understand until I show you. So like, we got our, let's create another like function right here. I'm gonna create a function right there, and you see, if we are creating like a new database, we can actually, this is the one that you can spend by this, but basically if we are creating a database, we can put in like MySQL database or a database and Oracle database. So that will have a new function, so we can just do like a quote new, not like this, but yeah. And then we can also have that fetch data, so like database dot fetch data. So we can have this database dot fetch data function, which is going to be generic, so it won't have something weird like fetch data from MySQL, something like this. It's pretty generic, and this one is the one that I really like. I don't know why, but it's better to use type generics for stuff that you want with different types, because like MySQL can have different configuration as well, like it can have different fields as well. So like hello, it can have different yeah, you know, it's actually the implementation, so I don't look at it. So it can have different fields. So it can have different fields like hello and any configuration, and that will still work. This is something pretty cool, and use type generics is pretty cool because we're using database, so you can't pass anything like string or stuff like this. You can only pass database into it. Now you can not just pass simple trait because it's a trait, it's not a struct or not a type specifically. It's just like an implementation stuff. So now we have talked about all of this stuff. Let's talk about the deeper part, which is it really worth it? Like, why would anyone want to move the existing code base and make it more clean and maintainable? And why will he use the S.O.L.I.D principle in the first place? And my only answer to it is good. By applying these principles, you will be equipped to write maintainable, extensible, and reliable software that stands the test of the time. Now, this is something you can use to flex, or this is something that will make you a better engineer. So, congratulations, you now have a comprehensive understanding of the S.O.L.I.D principles: single responsibility, open close, Liskov, substitution, interface segregation, and dependency inversion. By applying these principles, you will be equipped to write maintainable and reliable software that stands the test of time. Thank you for joining me in this journey through the S.O.L.I.D principles. If you find this video helpful, don't forget to like, share, and subscribe. Keep coding, keep learning. Until the next time, happy programming.